Simplifying radicals. Before we begin with any examples, I just want to quickly run through an idea that was presented earlier in the year. The difference between a rational and an irrational number often is dealing with a square root or a radical. An example here, or an idea here. Hopefully you all remember that something like the square root of 4 is equal to 2. This is considered a rational number because it can be written as a fraction. You can call that 2 over 1, and then it can be turned into a decimal that either repeats or terminates. If I do the square root, also known as a radical, so at this level a lot of times you'll just say rad. If I do the square root of a non-square value, such as the square root of 7, because 7 is not a square value, this would produce a number that when written as a decimal does not repeat or terminate, so this is considered an irrational number. Now, we talked about this earlier in the year. There's not a whole lot that we're going to do with it right now. I just want to make sure that we go back and review that idea. If I did the square root of 25, I get 5, which would be considered a rational number. If I did square root 23, which is a radical that doesn't really break down or doesn't break down to where you lose your radical, it's considered an irrational number. If I have something that's blended, like 4 square root 3, also known as 4 rad 3, that would be considered irrational. So anytime you have that radical that does not get broken down, that puts you in the classification of an irrational number. If I did 2 plus square root 5, because that square root 5 cannot be broken down, that puts you into the irrational category. So anytime you have a radical that cannot be broken down to where it disappears, you are an irrational number. Okay? Now, let's start with our idea here. Example. I like to use an analogy. It's almost like going through airport security. In order to get out of a radical, you have to match what's called the index. So let's go through this, give you some vocabulary. Here's a radical. Radicals that don't have any number where my marker point is dancing around, that's called an index. If it doesn't have a number here, it's considered to be a square root, so it has a 2. So for a square root, in order for you to get out of the airport security or to walk through the airport security, you have to have something like 3 squared. Of course, we all know that 3 squared is 9. That means that this is the same as 3. Why? When it comes through the airport security, the implied 2 that's here will cancel or take that ticket and allow the 3 to come through without its ticket. It just becomes a regular 3. Okay? And that's really going to be what hinges on the lesson today. You want to know that this is your index, and you're trying to get your exponents to match that index. And this would be your base. So we've got a base, we've got an exponent, and we've got an index. Now, let's do a couple real quick examples just to kind of get us warmed up here. This is called simplifying radicals. It's called simplifying radicals. So, example 1, let's say that I have something like the square root of 48. And if you remember when we were factoring, we're going to pull out an old friend. We're going to do a prime factorization. I'm going to come over here to the side. I'm going to write 48, and I'm going to prime factor it. I'm only pulling prime numbers out. So I recognize that 48 can be divided by 2, which takes me to 24. 24 can be divided by 2, which takes me to 12. 12 can be divided by 2, which takes me to 6. 6 can be divided by 2, which takes me to 3. Now as I look at this prime factorization, my goal is to find pairs to get the ticket so my term or parts of my term can come out of the radical. And so what I'll do is I'll rewrite this rad 48 as 2 squared, 3. Now as I look at this, I recognize that each of these 2's can come out from the gate, so to speak, and they'll lose their 2 because the ticket collector is going to take that ticket. And so I'll go 2 comes out, 3 stays in. With 2 values of 2 coming out, 2 times 2 would be 4 on the outside. And this 3 doesn't have a ticket to get through, so it's staying in. And we'll call that 4 square root 3. We'll do another example because that would be our final answer there. It'd be 4 square root 3, which is an irrational number. Let's say that we have, we'll call this example 2, the square root of 75. And as you get more experienced with this, you'll be able to break these down really quickly. Right now, you may struggle. So you'll have to do this a few times till you get very comfortable with these numbers. 75, I recognize it like 3/4. I could divide by 3. Leaves me with 25. Well, 25 is a square value. It's 5 times 5. So I'm looking at 5 squared 3 in my airport security. It'll allow the 5 to come through because it matches that implied index of 2, and we can call that 5 on the outside, rad 3. 5 rad 3. You see, the problems go very quickly. We'll do a third example in this video. Let's say that we have, let's do an example where we have a number already on the outside. Let's say we've come into the problem, they've already let some numbers through, so we have something like 7 rad I'm thinking here, 45. There we go. So with this, we still have an index of 2. It's an implied 2 there. We're looking for pairs. So we take that 45 and we need to break it down. So we'll say 3 goes into 45 15 times, but 15 breaks down as 3 and 5. So this gives me a set of 3's. I could rewrite this as 7 square root 3 squared 5, which means that this 3 has the key to get out or to get through the airport security. So it would come out as a regular 3, and we can call this 7 times 3 square root 5. But 7 times 3 is 21. So you got 21 square root 5. That would be your final answer there. And this is a quick example, or quick number of examples, on how to simplify radicals.